Let's work some examples for factoring polynomials. Sometimes you'll just have a polynomial that you'll just need to factor out the greatest common factor, the GCF. In this case, all three of these terms, we could pull out a 2. We could not pull out an x or a y from the third one, so only a 2 can come out. So if a 2 comes out, then we have 2x squared y divided by 2, because we've pulled out the 2, gives us, we're just left with x squared y, plus 12xy divided by 2, we're left with 6xy, minus 98 divided by 2, which is 56, I believe. 49. Oh, that's right. And that's all you can do with that. What if you've got a quadratic, something in the form x squared plus bx plus c? Well, you always ask yourself what multiplies to give you c that adds to give you b. So what multiplies to give us negative 40 that adds to give us 6? Well, let's see. 4 and 10 will give us 40. We need one of those to be negative to get negative 40. If we want a positive 6, then we want the bigger number to be positive. We want the 10 to be positive. So 10 minus 4 would give us positive 6. So negative 4 and positive 10 go in here. We're done. What makes it more difficult is when there's a number in front of the x squared other than 1. So we'll look at that in a minute. What about this particular problem? Well, always look to see if you can pull out a GCF first. 3 can come out of both 48 and 75. 48 divided by 3 is 16. And 75 divided by 3 is 25. Now, this is a difference of squares. And what that means is that both of these terms, separated by a negative, always a negative, are perfect squares. It's a difference of squares. So whenever you have a difference of squares, you always have this situation. Take the square root of, you've got plus and minus in here, okay? The square root of 16x squared is 4x. The square root of 25 is 5. Done. Now this last one, we're going to look at an example where the number up front is not 1, and it's not a perfect square trinomial or anything like that. So we have to, I factor by grouping. Now you may have learned a box method or a guess and check method or something like that, and whatever works for you is perfectly fine with me. But I do it factoring by grouping, so that's what I'm going to teach here. So the first thing you do is you find A times C. That's 6 times negative 15, negative 90. And we need to ask ourselves, what will multiply to give us negative 90 that will add to give us B? So the only difference here is we're not asking what will multiply to give us this, but what will multiply to give us AC that'll add to give us B. Okay? So what will multiply to give us negative 90 that adds to give us negative 1? Well, 9 times 10 gives us 90. One of them needs to be negative. and we want a negative 1 when we add, so the bigger number needs to be negative. So here's what we do. We bring down the 6x squared, and in place of the negative x, we split that into negative 10x minus 9x. And then bring down the 15, negative 15. Here's where the grouping comes in. Group the first two terms, group the second two terms. Factor the GCF out of the first two terms, factor the GCF out of the second two terms. So out of the first two, we can bring out of both 6 and 10 a 2, and we can bring out an x. 6x squared divided by 2x, we're left with 3x. Negative 10x divided by 2x, we're left with minus 5. And the next pair, I think we can just bring out a negative 3. 9x, negative 9x divided by negative 3 is 3x. Negative I messed up here, didn't I? This was supposed to be a plus 9x. So we're going to bring out a positive 3. 9x divided by 3 is 3x. Negative 15 divided by 3 is negative 5. There we go. You want these two things in here to end up the same. That's where I caught I was wrong. I was ended up with a plus 5. I was like, wait a minute, something is wrong. Okay. So we want those two things to be the same. And what we do is we write one factorization with the numbers out front, 2x plus 3, and the other with the numbers with the terms that are the same, 3x minus 5. You're essentially factoring out a 3x minus 5. And now we have our factorization.